One of the features of LINQ is deferred execution. And what this means is that when you define a query, it doesn't actually execute the query. So you'll have a line of code that defines a query. My query retrieves products in the beverages category, for example. The fact that you've defined the query doesn't really execute the query. Nothing has been sent to the SQL server. Really, all you've done is you've defined the query that's going to run when it's time to retrieve the data. So to execute the query, you need to run code that forces the query reference to require actual values. In other words, you define the query, and then when you start displaying the results, that's when the query actually executes. That's deferred execution. LINQ to SQL takes this concept to another level, and that's called deferred loading. And you can think of deferred loading as deferred execution at the object level. So for example, let's say you have a query that includes customers and orders. And you're going to see all of the orders for customers in Spain. So the first thing you do is define that query, and then you display the customers. You're going to start displaying the first customer in Spain. Now at this point, you've retrieved the customers, but you haven't retrieved the orders yet. LINQ to SQL will generate a SQL statement to bring back the customers that are in Spain. But you haven't actually retrieved orders yet. Now, for each customer, you start displaying the orders. At this point, LINQ to SQL will generate a SQL statement to retrieve orders. So you have one query, but multiple SQL statements are generated. One to get the customers, and then one for each order for each customer. And that's deferred loading. Now, deferred loading is on by default, and the rule is that related objects are retrieved when you access them. So customers first and then orders. But you can configure this. You can turn deferred loading off by setting the deferred loading enabled property of the data context to false. And if you do that, related objects are not going to be retrieved at all. You can also control which objects are retrieved by using the load options property of the data context. So you could specify that you want to retrieve customers and orders, but not order details. Well, why would you do this? Why would you make changes to deferred loading? Well, let's say you have a query that retrieves customers, orders, and order details. And then you want to give users the option of how much data they want to see. Maybe the user wants to see all of the data, all of the customers in Spain, and all of the orders they placed, and all of the order details for those orders. Or maybe it's customers in Spain and the orders they placed and the total value of those orders. So if the user wants to see all of that information, you just leave deferred loading on. But then the user may just want to see the customers in Spain who have placed orders. In that case, you're going to use the load options and specify that you want customers and orders to be brought down but not order details. Or maybe all the user wants to know is customers in Spain who have placed orders. In that case, you'd turn off deferred loading entirely, and you'd only get the customers and not the orders and not the order details. And the benefit is that you write one query for all of this rather than 3 different queries. Now, if you don't need to track changes, then you can improve query performance by using read-only queries. And to do that, you set the object tracking enabled property of the data context to false. That will improve query performance somewhat because the data context now is not set up to track changes. There is, however, a consequence of this that you need to be aware of. This automatically disables deferred loading. So in our previous example, if you had a query that retrieved customers, orders, and order details, you'd only get the customers, not the related tables. So maybe a more common way to improve performance is to compile queries. What will happen is LINQ to SQL will parse the query and translate it into SQL statements at compile time. So this would be equivalent to using a stored procedure. Now, compiled queries can be local to a method or they can be shared across methods. So you may have a method which runs a query 15 times for 15 different customers. You might in that method compile the query so that the next 14 times it runs, it's faster. Or you might have a query display customers in region that takes as an argument a region and returns customers, and you're going to use this query throughout the application. You'd compile it and make it shared. We saw in the demos in the previous sections that when you run a LINQ to SQL query, LINQ to SQL will take your LINQ query and translate it into SQL statements and pass that along. There may be times when you want to write the SQL statement yourself. In that case, you can use the execute query method of the data context and pass the SQL statement as an argument. So in general, you'd do this if LINQ to SQL was not sufficient for a task you had. For example, you might want to use some transact SQL syntax that's not supported by LINQ to SQL, and in that case, you can directly pass the SQL statement. Or you may have existing transact SQL statements and you haven't converted them to LINQ to SQL yet. You can pass those directly using execute query. So let's go see these techniques in action. I have the More LINQ to SQL sample project open, and this project contains an object model based on the Northwind database. Let me open that. So we have in here customer, order, order detail, product, and category. And then we have several stored procedures that have been added as methods. So you saw all that in previous sections. So now let's run this. And the first thing we want to look at is deferred loading. So when I run this, I'm going to prompt the user what report do you want to run. I'll enter 1 if I want the default to happen. I'll enter 2 if I just want to see information on the customer, and I'll enter 3 if I want to see information on the customer and their order count. So to start off, I'll enter 1, and then we'll see what happens. So if I enter 1, I'm not going to do anything differently. I'm just going to come down and I'm going to run a query. I'm going to retrieve information on a customer. That's ALF key. And then what I'm going to do is display the company name, the city, and the region, and the count of orders. So at this point, let's go into the SQL profiler and see what's happened. We've run a single query on the customers table to retrieve information on ALF key. And now, I want to see how many orders have been placed. Customer.orders represents the number of orders for this customer, and I'm going to report on the count of that. And I see that 7 orders have been placed. And I see that we run a second query to retrieve from the orders table the information for any orders where customer ID is ALF key. And then we count through that and display that there are 7 orders. So that's what happens by default. Now let's run this again, only this time I'm going to enter a 2. I only want to see customer information. So now what I'm going to do is I'm going to turn deferred loading off by setting the deferred loading enabled property of the data context to false. Now I'm going to run that query on customer again, display the company name, the city, and the region, and again send a SQL statement to the customers table to retrieve information on ALF key. And now watch what happens when I display the number of orders. 0. And if I go to the SQL profiler, no SQL statement's been sent. So the default for deferred loading is that after I query on the customer, when I want to see information from related tables, then a query gets generated. That's deferred loading. But I've turned deferred loading off right now by setting deferred loading enabled equal to false. And so customer.orders does not generate a SQL statement, and as far as my local in-memory copy of the data is concerned, there are no orders. Now I can control this. I'm going to enter 3 to see customers and orders. And I can control this by using load options. So I'll create this variable load options as a new instance of the data load options class, and I can use that to specify load options. And I'm going to specify that when customers are retrieved, orders should also be retrieved. And I'm going to set the load options property of the data context to that. So now I've specified that if you get customers, you should also go get orders. So now when I run this, I see that there are 7 orders, and I also see that 2 SQL statements are sent. One to get the customer, and then also one to get the orders. Let's look at read-only queries. So I'll press B, create a new instance of the Northwind data context, and then set object tracking enabled to false. I now have read-only queries. Now my queries don't look any different. Here's now a query to retrieve customers in the US. It's a read-only query, but the query syntax, of course, isn't going to be any different. And neither is the statement sent to the SQL Server database. So let's finish this off, and there are customers in the US. What I've gained by making this read-only is a small increase in performance. Now let's look at a second example of using a read-only query. I'm turning object tracking enabled off, and I'm going to run our previous query. I'm going to run a variant of our previous query. I'm going to get information on ALF-key. Then I'm going to display the company name, the city, and the region, and the count of orders. Notice that it's 0. And the reason it's 0 is when I create a read-only query, I've turned off deferred loading. So now I can't get orders, and because I can't get orders, I also can't get the summary information for orders. So just be aware, if you're going to use read-only queries for an improvement in performance, it disables deferred loading. Now let's look at compiling queries. So this query, get customers in the USA, we saw a number of times in previous sections. I'm running this a fair amount, so I think I should compile it. So I'll create this USA customers query, and to compile it, I use the compile method of the compiled query class. And I pass to that my context, which is Northwind data context. And then I specify my query from customer in nwinDataContext.customers, where country is USA, bring back company name, city, and region. Okay, so now this is a compiled query. And so now when I run it, I'm going to specify USA customers, and I'm going to pass to it the instance of the data context, NWIND data context. And there are customers in the US. So this example is compiled local to a method. Now if I use this over and over again across methods, then I might want to make it static. And in this case, I have a customers in the USA compiled query sitting in the compiled queries class. Where is that? That's out here. This is a public class compiled queries. And here's my customers in the USA query. Public static, it's a func. I pass in the context, Northwind data context, and iQueryable of customer. And then the query name is customers in the USA. And again, I use compiled query.compile, pass to that the context, and then my query. From customer and context.customers, where customer.country is USA, select customer. And I also have a compiled query for customers in a region, which is going to take, in addition to the context, a region. So I'm going to pass a string to this. So customers in the USA only takes the context. Customers in a region takes the context and a region. So now when I come back to here, I can run my compiled query, compiled queries.customers in the USA, passing in my database context. And now, for each of the customers, I can show the company name, the city, and the region. There they are. And then when I want to see customers in Washington, I'll call compiled queries.customers in a region, pass in the data context and the region, and I can see customers in that region. So I have my choice of compiling local to a method or compiling at the static level and being able to call it from within my program. The last example here we'll look at is direct execution. And this gives me the ability to talk directly to the SQL Server, bypass the LINQ to SQL query translation, pass my SQL statement directly. So here, I want to get customers in the US. I'm going to use the execute query method of the data context, which is generic. And I specify that it's going to return instances of the customer class. And I specify here's my SQL statement to pass. And when that happens, I've sent that statement directly as is to SQL Server. And now I can display the information because what comes back in USA customers is an enumerable collection of customers. And they're the customers in the US. In our next example, we're going to do some updating. So the first thing I want to do is retrieve information on the customer ALF key through a normal query. I'm going to display the information before the update, so let's step into this. Now we're just going to display the company name, and contact title. Okay, so currently for Alfred's Futterkist, contact name is Maria Anders, sales representative. Now I'm going to store those because ultimately I want to set those back. And now what I'm going to do is make a change. And I'm going to directly pass this update statement. Update customers, set the contact name to Robert Green, the contact title to President. I am now the President of Alfred's Futterkist. And again, if we look in the SQL Server Profiler, that's the statement we sent directly. Okay, so now let's query the database and display that indeed that information has changed. And then we'll set it back. Again, using execute command, I'm going to build the SQL string based on what the contact name used to be, send that on here, and then display the customer information, and so I've set it back. In our next direct execution example, we're going to create a customer, ZZZZZ Consulting, Don Kiley, Sales Manager in Toledo, Ohio. And when we execute that, here's the insert statement we send to SQL Server. And then let's call the customers in region stored procedure to display all of the customers in Ohio. There it is. And then finally, we're going to delete it using a delete statement. And that sends the delete statement here. And there are no more customers in Ohio. A transaction is a unit of work. And all of the modifications in the transaction have to succeed, or none of them should succeed. The first modification is you take $100 out of savings, and the second is that you add $100 to checking. Both of those have to work, or neither of them should work. Because if only one works, somebody, either you or the bank, is going to be not too happy. So in a transaction, everything succeeds or nothing succeeds. Now the data context, it turns out, automatically creates a transaction for you when you call submit changes. So if you have code to add an order and then add order details, you're going to want all of that to be in a transaction. You can add the order without the details, but now you've got incomplete data, and you cannot add details without the orders because you can't have children without a parent. So let's say you're adding an order. You add the order record, and then you add order detail records. That's another good example of a transaction. Now, as far as the database structure is concerned, you can add an order without adding order details, but you don't want it because now you have incomplete information. And you can't add the order details if the order doesn't get added because you're not allowed to have child records without a parent. So your first thought would be, well, I need to create a transaction out of this. Create a transaction and then within that call submit changes. But as I said, it turns out you don't have to do that. The data context automatically does it. Now you can create your own transactions and you can use the transaction scope class to do that. And you'll do that if you need more control over your transactions or you need to start your own. Let's say you're calling stored procedures rather than using submit changes. You have an add order stored procedure and an add order detail stored procedure. In this case, you're going to have to create a transaction because the data context won't create transactions when you call stored procedures. Or if your transaction spans data contexts, then you're going to have to create a transaction. We just talked about adding orders and order details. Deleting them is a good example of cascading deletes. So the rule is if you delete a parent record, you have to delete all of the children. So if you delete an order, you have to delete the order details. You can't have order details in the order details table if there's no associated order. So you might think when you're deleting an order that you first delete the order and then you individually delete the order details. Well, with LINQ to SQL, you don't have to do that. You can use the delete on submit method to delete the parent, and then the delete all on submit method to delete all of the children for that parent. And then you call submit changes. And as we just mentioned, LINQ to SQL will automatically wrap this in a transaction for you. One of the jobs of the data context is to track changes. So it knows what changes have been made, and therefore it knows, when you call submit changes, what SQL statement to create. But you might want to know specifically what changes have been made. You can do that by using the getChangeSet method of the data context, and that will retrieve modified objects in what's known as a change set. And that change set has an inserts, updates, and a deletes property that will tell you the number of inserts, updates, or deletes that are currently being tracked. Now, if you want to get specifics, you can call the getModifiedMembers method of any entity class, and that will return an array of members of that class that have been modified. And so each element in that array is an instance of the modified member info class, and that class has an original value property and a current value property. So you can see what the value was and what it currently is. A couple things you can do with this. One is you could use this to track changes. You might want to log all data changes that have been made, who made them and when. The other place this becomes very useful is managing concurrency conflicts. So if you're looking at a record and making changes to it, but in the meantime I've made changes to it, and you have a concurrency violation, then you can use these techniques to manage that and give me the opportunity of overwriting the information or not. In a previous section, we saw how to create an object model with LINQ to SQL. And what we did is we dragged tables from the Server Explorer into the Object Relational Designer, and then Visual Studio generated code. And that code was classes that were mapped to tables and columns in the database. And that's how we knew, when we got information out of the database, how to populate classes, and we also knew when we made changes to the classes how to get that information back to the database. So your object model includes information on the structure of your database. And because it does, you can actually create a database from the model. You do that using the createDatabase method of the data context. Now typically what will happen is you'll have a database and you'll create an object model from that. Why would you want to go backwards? When would you have an object model and then go backwards to create the database? Well, you could do this to create the database if necessary when the application starts. So when the user fires up the application, you're going to check to see if the database exists, and you can do that by calling the database exists property on the data context, and if it doesn't exist, you can create the database. And then if you want to get rid of the database, you can call delete database. And let's go see these techniques in action. Let's look at transactions. So I'll press F. And in our first example of a transaction, we're going to create an order for a customer. So the first thing we'll do is get a reference to that customer, run this query. Now customer.alfkey represents the customer. We're going to create a new instance of the order class, pass in customer ID, order date, required date, and employee ID, and ignore the rest of the information, which is not required. And then we'll add that new instance of the order class to the collection of orders belonging to the customer. CustomerAlfkey.orders is a collection of orders for that customer. We'll add this new order to that. Then we're going to create order details by creating a new instance of the order detail class. Product 7 was in the order. We'll add that to the collection of order details that belong to this new order. We'll do another one for product 8 and another one for product 12. And then what we're going to do is submit the changes and save that information to the database. Now this should absolutely be in a transaction. I'm adding a parent and 3 children records. All of this should work or none of it should work. And as we said, when I call submit changes, that's automatically wrapped in a transaction. And I can see that order 1179 was added, and there are the 3 details. And again, and if we look at the SQL Server Profiler, here's the original insert to insert the order, and here are the 3 inserts for the details. And then here are the queries to retrieve that information. Okay, let's look at another example of transactions. Again, for Alpha, I'm going to add another order. This time I'm going to use stored procedures. I have an add order stored procedure, which I added in a previous section to the object model so I can call it as a method of the data context. Add order expects me to pass a customer ID, an employee ID, all of the information for the customer. So I'm going to do that. And now, when I call add order, here's what's sent to SQL Server. A call to the add order stored procedure, and what comes back is the actual order ID. And I need that information because I'm now going to call the add order details stored procedures to add order details for this order 3 times, passing the order ID, the product ID, the quantity, the price, and the discount. So I'm going to call add order detail 3 times. And that will make 3 calls to the add order stored procedure. Now at this point, this is not in a transaction by default. The data context is not going to create a transaction when I call stored procedures because it doesn't necessarily know that these are related. So what I need to do is create a transaction myself. So I'll create a new instance of system.transactions.transactionScope, and then within that, I'll have the calls to the stored procedures wrapped in a try-catch. I'm then going to call transScope complete to commit the transaction. If anything fails, then there'll be an exception. And in fact, this did fail. The transaction has aborted. The reason the transaction is aborted is because it timed out. So let's stop this. Let's run it again. And let's be a little more quick about this. So let's do the first one. And now I create a transaction. I call the 3 stored procedures. 1, 2, 3, and then I complete this. And this time the transaction works. Okay, let's look at one more example of a transaction. This time I'm also going to roll my own transaction. I'm going to call add order and add order detail 3 times, but this time I'm going to specify a product that doesn't exist, 777. There is no product 777, so I would expect the call to transScope complete to fail. So let's run this. And I get an error. The insert statement conflicted. Notice, however, if we go into the profiler, that we've called add order detail and add order. We called add order, so the order was added. The first call to add order detail is going to fail. And the statement's been terminated. So if we now go into Server Explorer, connect to Northwind, and look at the orders, we'll see that we were working on 1183. That failed. Okay, let's look at cascading deletes. We know that adding orders should be in a transaction. Same thing with deleting them, but let's look at how we delete. So the first thing I'll do is show the orders for LINQ. There they are. 1182 was the last one. Now what I want to do, now I know 1182 is the last one because I can look at it, but let's figure that out in code. So let's do a query to retrieve the maximum order ID for LINQ. This will show me the most recent order that anybody added, not necessarily me. It's 1182. Now I want to retrieve information for that order. I'll do a query to bring back that order. So now last order is an instance of the order class representing order number 1182. So I want to delete that. So I'll call delete on submit of the orders property of the data context and delete the order. And then I want to delete the order details, so I can call order details delete all on submit and pass last order.order details. So that will delete all of the order details for that order. And when I call submit changes, that's wrapped in a transaction. And now that last order is gone. We know that one of the jobs of the data context is to track changes. Let's see how we can see what changes have been tracked. So let's retrieve information on a customer, LINQ, and then let's make a change. We'll change the contact name and the contact title. So I think in a previous demo I was the president, now I'm the vice president of LINQ. I guess that's a demotion, huh? Let's also bring down information on another customer, ANATR, and they've decided to move to Eden Prairie. So we'll change the address, city, region, and country. Well, this has all happened in memory. None of this has gone to the database server, of course. But the data context is tracking it. So let's find out what it's doing. Let's call the getChangeSet method of the data context, and that will return a change set. And the change set has an inserts property, which tells me the number of inserts, an updates property that tells me the number of updates, and a deletes property that tells me the number of deletes. And so I can now see that there are 2 updates pending. The first update was to customer 1, the second was to customer 2. Well, let's find out exactly what those changes are. So I'm going to call the getModifiedMembers method of the customers property, and I'm going to pass to it customer 1. And that's going to bring back an array of modified member info called custChanges. And so for each modified member info in that, I can get the member name and the original value and the current value. So I'm going to do that for all of the changes for customer 1, and I can see that for that first customer, the contact name was changed and the contact title was changed, and I see the original and the current value. And then I'm going to do the same thing for customer 2. So here's the address, the city, the region, and the country. So I could use this to confirm to the user these are the changes that you want to make. I could use this information to log changes that have occurred. Maybe I want to write it to a database or maybe to a text file. I can also use this when there's a concurrency conflict. Finally, let's look at creating and deleting a database. Now I know that my object model, Northwind, contains customer, order, and several other classes. I know it contains stored procedures, and I know that when I created it, Visual Studio generated this code. And I know that in this code, which is my object model, is the information on how it maps to the database. So I know that the Northwind data context maps to the Northwind database. And I also know that the add customer method maps to the add customer stored procedure. And I know that the customer class maps to the customers table, and for example that the customer ID property maps to the customer ID column, which is ncar5 not null. So I can reverse engineer that and create a new database. So the first thing I'll do is create a connection string that says connect to SQL Express to the Northwind v2 database. And then I'm going to create a new data context based on that. So I've now created a data context connecting to Northwind v2. Now, of course, I don't have, at the moment, a Northwind v2. Let's just confirm that. There is no Northwind v2 at the moment. So I'm going to create it. I'll call the create database method of that data context, and that is going to connect to the SQL Server and create Northwind v2. Well, let's go into the Server Explorer, create a new connection to SQL Express. And now here's Northwind v2. Let's connect to it and see what's in it. Here are the tables with all of the columns I would expect. And are there stored procedures? No, because the object model doesn't contain the definition of the stored procedures, just the mapping. So I guess we could have predicted that's not going to come over. So now let's disconnect from this. Let's actually delete this. Remove the database connection, because now what I want to do is delete the database. So if it exists, then let's delete it. And so now I can come back into the Server Explorer, create a connection to SQL Express, and that database is gone. We've seen that when you create an object model based on a database using LINQ to SQL, Visual Studio generates the code that defines your object model. And each of the entity classes in that model is generated as a partial class. And the benefit of a partial class is that you can extend these. The Visual Studio generates an onloaded, an onValidate, and an onCreated partial method for each entity, as well as an onChanging and an onChanged partial method for each property. How does this benefit you? Well, this gives you the ability to add custom business logic to your data model by adding code to these methods, or actually creating your own partial methods. So for example, you could create an onCreated partial method for an entity class and write code that should run whenever an instance of that class is created. So you might put code in an onValidate of the order class to validate the order date against the required date. Or you might put code in the onCreated method of the product class to set the discontinued field to false as the default. You can use the onChanging partial method for a property to validate that property. So in the onChanging of the unit price, you might put in the code that says price can't be less than 0. So now validation is part of your object model. And the CLR will throw an exception if you call submit changes and there's invalid data. Let's go see this. When we created our object model by dragging tables from the Server Explorer onto the Object Relational Designer, Visual Studio generated code. And we've taken a look at that code in previous sections, but let's go back in and look at it again, because I want to see the entry points Visual Studio provides for data validation. So let's go to the definition of the order class. And we can see that it maps to the orders table, it has various properties. There's also a region called Extensibility Method Definitions. If we expand that, here are the partial methods that Visual Studio generates for this order class. OnLoaded, OnValidate, OnCreated, that's at the order level. And then there are changing and changed methods. And then there are onChanging and onChanged partial methods for each of the properties. So for example, if we wanted to validate the order date, we could create an onOrderDate changing partial method ourselves and then write code. And that's exactly what I've done in the data validation file. I want to add to the order class. this order class is created as a public partial class, and the benefit of a partial class is that the class definition can reside in two different files. So most of it is in northwind.designer.cs, but I can also put some of it in data validation. And I want code to run when an instance of orders is validated. So I'm going to create a partial method on validate in here, and it uses the same signature as this on order date changing. So I basically just copied this code and pasted it in here. Now onValidate takes an argument action, which is a system.data.link.change action, which describes the type of change. And so I can check to see if the change is an insert or an update or none. So if we're currently inserting an order, I want to check to make sure that the order date is not before today. So if this .orderDate is less than system.datetime.today, then I'm going to throw an exception. Order date can't be before today. And this represents the current instance of the order class. I also want to validate that the required date can't be before the order date. Now if we're making changes, I again want to validate the required date can't be before the order date. So my rules are order date can't be before today, and required date can never be before the order date. And then I also want to prevent anybody from changing the order date once an order's been added. Now I'm not going to do that, obviously, in the onValidate, where the action is an insert, because you have to set the order date. Then after that, I want to prevent the order date from changing. So I'm going to use the onOrderDateChanging method, and that takes as an argument a value, which is a nullable date time. So this value represents what the date is changing to. So if that value is not the same as the current order date, and also the order date has a value, then I'm going to throw an exception. If the order date doesn't currently have a value, that means we're adding a new order, and you can certainly enter an order date. We're going to trap to make sure that order date is not before today up here. So if the order date currently has a value, then you must be modifying an existing order date, and unless you entered the same date, I'm going to throw an exception. So let's put some breakpoints in here. And run this example. So I'll press J for data validation. So I'm going to retrieve information for ALF key, and I'm going to create a new order. And I'm going to pass customer ID ALF key. I'm going to pass the order date as yesterday, and the required date is 7 days from today. So the order date is today minus 1 day. So now that triggers the onOrderDateChanging. This order date doesn't currently have a value because it's a new order. So we're not going to worry about that. But now we're going to validate the order. What's the action? The action's an insert. The order date of yesterday is before today, and therefore we're going to throw an exception. Order date can't be before today. So let's go back to the program. And I'm going to wrap my submit changes in a try. And if an exception is thrown, which it was, display the message. Okay, let's do another example. Let's try to change the order date of an existing order. We'll bring down order 10248. And we can see that the order date was 7/4/1996. So now, wrapped in a try, we're going to change the order date to today. This triggers the onOrderDateChanging. Order date has a value, and it's 7/4/1996. We're going to change it, and therefore, we're going to throw an exception. we catch that and display the message, which is can't change the order date of an existing order. All right, now let's try to set the required date before the order date. So for this same order, we were not able to change the order date. Let's try and change the required date. We're going to set that equal to the day before the order, and we're going to submit the changes. This triggers the onValidate. What's the action? The action is update, and we're going to check to see if the required date, which is now July 3rd, 1996, is before July 4th, which it is. So we'll throw an exception, and then we will display that. Can't change the order date. Required date can't be before the order date. New orders can't have the order date before today. That business logic is built into the model through the use of the partial methods. So again, if you go into the designer, you can see all of the partial methods that Visual Studio creates, and you can put your business logic in any or all of these, and then have that business logic be part of the model.